Hello everyone, welcome to our channel AskPrep. In today's series on 11th grade physics, we will be studying chapter 2, Units and Measurement, in detail. Let's start the video. Starting with definitions, what is measurement? The process of measurement is essentially a comparison process. To measure a physical quantity, we need to determine how many times a standard amount of that physical quantity is present in the quantity being measured. The number obtained is known as the magnitude, and the standard chosen is called the unit of the physical quantity. Next is unit. The unit of a physical quantity is an arbitrarily chosen standard that is widely accepted by society and in terms of which other quantities of a similar nature can be measured. Next is standard. The actual physical embodiment of the unit of a physical quantity is known as the standard of that physical quantity. To express any measurement, we need the numerical value, n, and the unit, mu. Measurement of physical quantity is equal to numerical value times unit. For example, length of a rod is equal to 8 meters, where 8 is the numerical value and m, meter, is the unit of length. Moving forward with fundamental physical quantities units, a fundamental physical quantity is an elementary physical quantity that does not require any other physical quantity to express it. It cannot be further resolved into other physical quantities. It is also known as a basic physical quantity. The units of fundamental physical quantities are called fundamental units. For example, in the MKS system, mass, length, and time are expressed in kilograms, meters, and seconds, respectively, and these are fundamental units. Next is derived physical quantities units. Derived physical quantities are those that can be derived from the combination of two or more fundamental quantities or can be expressed in terms of basic physical quantities. The units of other physical quantities that can be obtained from fundamental units are called derived units. For example, the units of velocity, density, and force are ms, kg m superscript 3, and kg ms superscript 2, respectively, and are examples of derived units. Next is systems of units. In the past, different unit systems were used in different countries, including the CGS, FPS, and MKS systems. Today, the C system of units is followed internationally. In the C unit system, 7 quantities are taken as base quantities. 1. CGS system, centimeter, gram, and second are used to express length, mass, and time, respectively. 2. FPS system, foot, pound, and second are used to express length, mass, and time, respectively. 3. MKS system, length is expressed in meters, mass in kilograms, and time in seconds. 4. C units, length, mass, time, electric current, thermodynamic temperature, the amount of substance, and luminous intensity are expressed in meters, kilograms, seconds, amperes, Kelvin, moles, and candelas, respectively. Next up is definitions of fundamental units. You can see in the image. There are some fundamental units like length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Advantages of the C unit system. The C unit system has the following advantages over others. 1. It is internationally accepted. 2. It is a rational unit system. 3. It is a coherent unit system. 4. It is a metric system. 5. It is closely related to the CGS and MKS systems. 6. It uses the decimal system, making it more user-friendly. Other important units of length. For measuring large distances, such as the distances of planets and stars, larger units of length like the astronomical unit, light year, and parsec are used. Astronomical unit, the average distance between the Earth and the Sun. 1 astronomical unit is equal to 1.496 times 10 to the power 11 meters. Light year, the distance light travels in a vacuum in 1 year. 1 light year is equal to 9.46 times 10 to the power 15 meters. Parsec, the distance at which an arc length of 1 astronomical unit subtends an angle of 1 second at a point. 1 parsec is equal to 3.08 times 10 to the power 16 meters. Size of a nucleus. 1 Fermi is equal to 1 FM is equal to 10 to the power negative 15 meters. Size of an atom, 1 angstrom is equal to 1 A is equal to 10 superscript 1 M. Dimensions. The dimensions of a physical quantity are the powers to which the fundamental units of mass, length, and time must be raised to represent the given physical quantity. Dimensional formula. The dimensional formula of a physical quantity is an expression indicating how and which of the fundamental quantities are involved in the unit of that quantity. It is customary to express the fundamental quantities by capital letters like length, L, mass, M, time, T, electric current, I, temperature, K, and luminous intensity, C. We write the appropriate powers of these capital letters within square brackets to get the dimensional formula of any given physical quantity. Applications of dimensions. The concept of dimensions and dimensional formulae is used for the following. I. Checking the correctness of results. 2. Converting from one system of units to another. 3. Deriving relationships between physical quantities. 4. Scaling and studying models. The underlying principle for these applications is the principle of dimensional homogeneity. According to this principle, the dimensions of the various physical quantities on both sides of a permissible physical relation must be the same, and only dimensionally similar quantities can be added or subtracted from each other. Limitations of dimensional analysis. Dimensional analysis has the following limitations. I. The value of dimensionless constants cannot be calculated by this method. 2. Equations containing trigonometric, exponential, and logarithmic terms cannot be analyzed by this method. 3. If a physical quantity in mechanics depends on more than 3 factors, a relation among them cannot be established, as only 3 equations can be formed by equalizing the powers of M, L, and T. 4. It does not indicate whether the quantity is a vector or scalar. Error. The measured value of a physical quantity is usually different from its true value. The result of every measurement by any measuring instrument is an approximate number that contains some uncertainty. This uncertainty is called error. Every calculated quantity based on measured values also contains some error. At last, here are some basic concepts go through with the image. Thank you for watching. We will be dropping notes in the description of this video. If you found this video helpful, kindly like, subscribe, and share. See you in the next video. All the best for your exams.